Hello guys and girls, Raj here, back with another video. Migrating your application from your local machine to Kubernetes in the cloud could be a little tedious. There are a lot of steps involved. So in this video, we are going to go over step by step to take your local application to Kubernetes in cloud. So we are going to start with running a program in local machine. No containers, just a regular program. Then we are going to containerize the program. We will learn how you can create the container image from the program using Docker image. And then we are going to run this container in the local machine and test it out. Then we are going to deploy this container to cloud, in this case AWS EKS. Then we are going to expose this container to the whole world so that you can call this program from anywhere. And finally, we are going to scale the container. And all these steps will be covered with demo. I have given timestamp for your viewing convenience. All right, with that, let's get started. All right, so step one, where it all starts, your local machine. So you, the programmer, do the coding in your local machine, and then you run it in local machine. For this example, I'm going to go with a Python code. So note the command, right? Python // which is basically the same folder, server.py if the name of the code is server.py. So this will come into play later on. So let's do this step one as demo. So let me jump into Visual Studio Code. Okay, so this is the code, pretty simple code, a Python code which is importing Flask and then just returning hello world and then running it in 0.0.0.0, so basically localhost. So generally what you do is, since this program is importing Flask, you have to install Flask in your machine. So you do that using pip install Flask. Okay, so I already installed Flasks. That's why it says requirement already satisfied. But you do need to install Flask if you want to run this program locally. So once you install Flask, so see the name of the program is server.py. I am in the same folder in the command line. So I'm just going to run python // server.py. Okay, so my Python code is up and running. So if I open this localhost :5000, so I'm going to type localhost :5000. All right, so our Flask program is returning hello world. Okay, I'm going to press Ctrl+C to stop the execution. All right, so everything is running from local machine. There is no container, nothing at this point. Okay, step one is done. Now what we are going to do is we are going to containerize the code, but still in the local machine. So to containerize the code, you need to create a file called Dockerfile. A Dockerfile is a text document that contains all the commands a user could call on the command line to assemble an image. So in this case, we are going to go through the Dockerfile in detail. Remember, we installed the Flask, and then we ran a command, python space name of the code .py, right? So all that needs to be in the Dockerfile. So basically, you are telling what things needs to be packaged in the container. So when we run this Dockerfile, by running command docker build, it will create the container image, and this image will be in the local machine. So let's take a look at the Dockerfile. So on the left, we have our program, and on the right is the Dockerfile. So the first line, which is from Python :3.8, what it is doing is it is grabbing a base container image which has Python installed. So literally the name of the container image is Python. So if I go to DockerHub, okay, so I'm in DockerHub, I'm going to search for Python. So you see this name of the container image Python. So literally when you say from Python, it goes to DockerHub, grab the container image Python, and then it grabs the image which has a tag of 3.8. So if I scroll down, you can see the simple tags. There should be an image with 3.8. So you can see there is a 3.8. So if I click that, Python 3.8. So this is the image that will be pulled, and that will be your base container image. So it makes your life easier. So let's say if you are working with Node.js or you are working with some other programming language, you can start with the base container image which has those programming languages loaded. If you want, you can build this base image as well. So instead of getting a base image from DockerHub, you can do from scratch. And that will be like an empty container image. Then you can install Python or whatever other library that you want. And then the work directory, the regular Linux command, set the working directory in the container. And then generally for Flask or Node.js, for external dependencies, in this case Flask, you put all that in a requirements.txt file. And then I copied the requirements.txt to this work directory /code folder, and I'm running a pip install. If you remember in the local machine demo, I ran pip install and then Flask. So that's what it's going to do, pip install, and then recursively go through all the lines of requirements.txt and install all the dependencies. In this case, requirements.txt only has the Flask version 1.1.1 line, so that's what it's going to install. And then it's going to copy the server.py, that's the name of the program, to this work directory as well. And finally, the cmd is the command that is going to run as soon as this container comes up. So remember, I told you to remember how we are running the code in the local machine. We are running the code by executing python./server.py. So exactly the same way, if I go back to the Dockerfile, it is saying command run python space ./server.py. So it will start the program. So the difference between run and cmd commands are, they are both Dockerfile instruction. Run lets you execute commands inside of your Docker image, and cmd lets you define the commands to run when your container starts. Okay, so at this point we have the container image. So then you run the container in the local machine using docker run. All right, so let's do this part. Let's build the Docker image and then do docker run. So let me jump back into Visual Studio Code. Okay, so in the Visual Studio Code, I have my Docker file that we went through and requirements.txt. So to run Docker commands, you do have to install Docker in your machine. So I am using Windows, so I have a Docker desktop for Windows. I'm going to start this Docker desktop. And when the Docker desktop is running, you can see this Docker desktop running icon. And you can also test it out by running docker -- version, and it should show you the version. All right, to run this Docker file, which will create the Docker image, you run the command docker build, and then we are gonna do a tag, but we are not gonna give a tag, so it's gonna get created with the latest tag. And now you have to give the name of the image. How about YouTube Flask app. And then dot means it's in the local folder. All right, so let's run this. It ran those commands and then it created the image. So if you want to see the images that's in your local machine, you can run Docker images and you should see all the images. So the images that we just created is YouTube Flask app with the tag latest. All right, now to run the container, we are going to use Docker run and then -d means the container will keep running in the background, and -p means we are going to publish the container's port 5000 to the localhost 5000. Because by default, the Flask app will run in the container and it will expose on the port 5000 on the container, and we are just mapping that 5000 to the host's 5000. In this case, host is the local machine, so we are exposing it to 5000. The first 5000 is the container port, and the second 5000 is the host port. And finally, we are giving the name of the image, YouTube Flask app, to tell the command which container image to run. All right, press enter. Okay, so it just gives an ID because remember it's running on the background. So if you want to see which containers are running, you can run Docker ps and you can see the image YouTube Flask app is running. The re-entry command is python./server.py and it created 27 seconds ago. So at this point, we should be able to access it using localhost 5000 like before, but this time it's running in a container in your local machine. Okay, let me type in localhost colon 5000. Here we go, hello world. Another handy command is docker logs. If you want to see the logs in the container that's running, so you can run docker logs and then give this container ID. So I'm just going to copy this, paste it, and here you go. It says running on this 5000 port on localhost, and as I ran it, it shows that it's doing a get and the return code is 200. I ran it twice. Okay, so at this point, we have Dockerized our application, created the container image, and running the container image in the local machine. So now the next step, preparing for the cloud. To run this in the cloud, you need to move it to a container image repository, right? Because the cloud Kubernetes cluster cannot really read the container image or grab the container image from your local machine. So for our case, we are going to use DockerHub, and we are going to push the container image from the local machine to the DockerHub. All right, so let's jump into the console and do this part. Okay, I am in DockerHub, so I'm going to create a repository in the DockerHub. I will name this as Flask Demo. I'll create this as public repository for this demo, and then click create. All right, so let's now tag our container image and then run this Docker push. Going back to Visual Studio Code. All right, first I have to log in to my DockerHub from the command line. So Docker logging. All right, so now I have successfully logged in. Now if I type Docker images, so YouTube Flask app is the container image that I need to tag and then push it. So to tag a Docker image, you run docker tag and then the ID of this image and then the name of your repository and then the tag. So I'm going to copy this from here If I don't give a tag name, it will be latest. So for this demo, I'm just gonna keep it empty. So it is gonna get pushed with latest. All right, so the image is tagged. So if I run Docker images again, you can see that we have the Docker image ready. To push these images, we are going to run Docker push. And again, if I don't specify a tag, it is gonna pick up the latest tag. All right, looks like the image is pushed. So let's check it out. All right, so we have the image with the tag latest, and this is the full name. All right, so at this point, we have successfully pushed the container image to DockerHub. So now the next step is to deploy this container image into our Kubernetes cluster. So to do this deployment, we are going to use kubectl commands. All right, so let's spin up a EKS cluster and then try to deploy this. I'm going to create a EKS cluster by using EKSctl command. So I'm just going to run EKSctl create cluster. All right, our EKS cluster is up and running. So if we run kubectl get pods, you can see nothing is running yet. So generally, to deploy a container image, you create a deployment file, right? Let me show you guys and girls a cool trick. So this is how you can generate a deployment file from the command line instead of copy pasting the whole thing. kubectl create deployment, and the name of the deployment, how about we give it Flask demo, and then you give the image, and this will be the name of the image, this, and this is the important part. You put dry run equal to client. So basically this is not gonna run it, and then you give output mode YAML, and then you give name of the file. How about flask deployment.yaml? Okay, that should create a flask deployment.yaml file. And if I open this, you can see it created this deployment with the image with one replica. So if I deploy this, kubectl apply -f flask deployment.yaml. Okay, kubectl get pods, and you can see one pod of the Flask demo is running. All right, so at this point, we deployed our container image to the Kubernetes cluster as a pod. So now we are coming to the end game. Now we have to expose our container to the world. How do you expose it? So you create a service and then you point that to the pod. We are also going to go one step further. We'll do these two together. We are also going to scale the container. So we'll scale it using a replica set for this demo. Okay, let's go back to our deployment file. Okay, let's make the replicas as 3, and that will create 3 pods. And at the end, we are also going to create a service. So kind is service, name is load balancer service, type load balancer, and this is the important part. So the port incoming traffic will be coming at port 80 in the load balancer. However, it will target port 5000 for the container because the Flask app runs by default on port 5000. And the selector is app Flask demo. So if we go up, that's the label for our app Flask demo. All right, so let's save this and then apply this file. Okay, so if we run kubectl get pods again, okay, 3 pods are running. If we run kubectl get service, our service should be coming up. We'll give it a minute or two, then we'll try this load balancer URL. All right, so let's copy this load balancer URL and then paste it in a Chrome tab. All right, so our service is working. Now we are reaching our pod running on an EKS cluster using a load balancer service. All right, so we started with running a program in the local machine. Then we containerized the program using Dockerfile. We ran the container in the local machine. We deployed the container to the cloud, in our case, EKS cluster in AWS. We exposed the container to the world, and we also scaled the container. So what are some of the things you guys and girls should think about next? Logging and monitoring. And then think about how to run multiple apps in the cluster using namespaces. And then for the scaling, we just did the replica set. But then you should think about how to do horizontal pod autoscaler, cluster autoscaler. I have a separate video on those, detailed video. I'm gonna give the link up top as well as in the description. Then think about DevOps. I also have a separate video on Kubernetes container DevOps. Check that out. Then go one level deeper and think about ingress. Again, I have a deeper video on ingress. I did not want to jam everything in this video because it will be like super long video. And then think about the best practices such as how to optimize the container, how to cost optimize, performance optimize, how to achieve day 2 operations, security, etc. All right, guys and girls, that is the video. If you like this video, please click the like button, smash it if that's something you are into, subscribe. Also, let me know if you have any questions on those steps that we went through or any suggestion for my future videos. All right, that's it for this time. I'll see you guys and girls in the next video. Bye.